Welcome back. Let's solve some equations. And this is actually easier than having to simplify the roots, the various types of roots. So what we're going to do here, well, actually get the concept from this first one. The square root of x is equal to 3. Remember that you can do the same thing. You can do anything to one side of an equation, such as square it, as long as you do the same thing to the other side. And a square root and a square cancel each other out there. So we have x is equal to 3 squared is 9. That's simple. Solve means find out what x is. And that's what I just did. If I put x9 back in here, I would have square root of 9, which if you take the square root of 9, that's 3 squared. They cancel and you get 3. So that means it was correct. There, checked. Now let's do it where there's something more in with the x. We're actually going to do the same exact kind of thing. Okay? So I am going to do this as x plus 4 equals 9. If I square that, this and this cancel out. I have just x plus 4. And over here, I'm also doing a square, so I get 81. Well, now it's just solve for x. Minus 4 and minus 4, so that I get the x by itself. 81 take away 4 is 77. And if I put 77 in here, 77 plus 4 is 81. The square root of 81 is 9. Then I have just solved this. This is correct. Okay. Now, actually, I should make the box include the x there. So I'll do that. It's just easier to see that it's the answer or solution to it. And so I'm going to do that over here too. I guess it wouldn't take off points if someone didn't do it, but it does when you're solving. The idea is to get what x is, so you can say x equals. We're going to do the same concepts here for C and D, but these two you have to clean up first. Clean up first. That means when you look at A and B, there was nothing on this side of the equal sign except the square root. There was nothing on this side except the square root. There was stuff inside the square root, but not outside of it. Now there is something outside of it. There's this minus 2, and over here there's this one that's a 6 times it. So what we have to do is the opposite operation to get it out of that side. And so we can do one thing, anything on one side of an equation, as long as we do the same thing on the other side. So now we have the cube root of x plus 4 equals a 3. And this is where, now when I look at it, I can do this because I can do a third power here as long as I do the same third power here. Perfectly fine to do that on both sides, and I'm choosing to do it because if this index is 3, I need a cube to cancel them out, to cancel that out. And in doing so, I now have just the x plus 4 on this side, and 3 to the third power is 27. I can subtract 4, so I get x equals 27 take away 4 is 23. And if I put 23 in here for x, plus 4, I get 27. The cube root of 27 is 3. Take away 2 is 1. So that shows or proves that this is the correct answer, the correct solution for this. I have solved it and found what the correct x is. And I'm going to do the same thing over here now. This is a good one to stop with. Here, this is 6 times it, so I have to use the opposite operation. You do that first. Go through and do this one yourself and see what you get. Pause the video, come back, and I will start doing it. Well, welcome back. I will divide here by the 6. And because this is one overall term, 6 times something, the 6 is there, cancel. And over here, I would get a 7. So I now have the square root of x plus 4 is equal to 7. Okay. I'm going to rewrite it to make the next step clearer. I'm going to now square this so that these cancel, but I also have to square that. So I have x plus 4 alone there because the square root's gone because I squared it. And over here I have 49. Yeah, subtract 4. X equals 45. If I went back up here and put a 45 in for that x, I get square root of 49, which would be 7. And 7 times 6 is indeed 42. So that's a good way of checking it and seeing that that's the correct answer. Here now is a more complicated version of this, where now there's two things on the outside of it. On this one above it, I have this minus 2. Now I have a minus 12. And I have a multiplication of a 5. All right, that really isn't going to cause me any trouble if you think about it. Let me draw a line down here to separate these two problems. All I do is the same type of thing as before. I'm going to add 12 first on both sides. I have a 5 outside of the square root of x plus 4. Negative 7 plus 12 is a 5, or 12 take away 7 is a 5. Now I'm going to divide by this 5, so those cancel out. I'm going to do it on both sides. So I get the square root. Let's bring that back. The square root of x plus 4 is equal to 1. Oh, well, let's square that so that these cancel, and square that. So I get x plus 4 is equal to 1 times 1 is 1. Let's do minus 4, so we get the x by itself. X is negative 3. Let's go back up here and put it in there. Negative 3 plus 4 is a 1. Square root of 1 is 1. 5 times 1 is 5. Take away 12, I'm at negative 7. Indeed, negative 3 is the correct x that will make these two sides of the equation correct. So what I just did here with that negative 12 and the 5, do that over here with this one. You'll start with that negative 3, and then you deal with that 6. Go for it. Go and do that. Pause the video. Come back to it when you have it done, or when you've tried it and think you have it right, or if you get lost, come on back and watch me do it. Well, welcome back. Let's do now these steps. And as you've seen me do many times, I do the adding or subtracting one first. So I have 6 fifth root of x plus 1. This became a 0, and 9 plus 3 is 12. That 6 is multiplying towards the fifth root. So if I divide it on both sides, I will cancel out that 6. So now, fifth root of x plus 1 is equal to 12 divided by 6 is 2. So now at this point, I'm going to rewrite that just to make it more clear what it is I'm doing on both sides. I'm going to do the fifth root now because it matches the index, and that means all of that cancels here. And I have x plus 1. 2 times 2 times 2 times 2 times 2 is 32. X equals 31. Now, if I come back up here and I put 31 in for that x, 31 plus 1 is 2, or 32. The fifth root of 32 is 2. 2 times 6 is 12. Minus 3 is 9. So I just did each of those steps very quickly. If you wrote that out on paper, some of you would see better. But I just did all the work associated with it. Maybe I'll show that here by doing sixth root. Oh, not sixth root, fifth. 6, fifth root of 31 plus 1 minus 3. 6, fifth root of 32 minus 3. The fifth root of 32 is the number 2. 12 take away 3, 2 times 6 is 12. 12 take away 3 is 9, and 9 is what we were trying to get to. So that checks that x equals 31. That's definitely and clearly the correct answer there, because when you put it back in, it makes both sides equal. Now let's take a look at radical equations, starting with fractional exponents. So what we're going to look at here is what can we do? It would be perfectly fine for me to take this and do the square root of x equals 4. Whoops, now. Square root of x equals 4. And then square both sides. But I want to introduce you to a different concept with this. And that is, if my goal is to get the x by itself, one of the techniques that I can use here is to multiply up here by the reciprocal of that. So I can basically I can square this side because 1/2 times 2 will be a 1. And if I do 1/2 times 2, I get x to the first power, and we don't even show the first power. We just get, there's the x, and we get the answer on the other side we need. And if I'm going to do a square here, I also have to do a square here. So I get 16. Oh, so 16 to the 1/2 power would be equal to 4. And if I put it over here and did square root of 16 equals 4, that confirms it too, because square root of 16 is 4. So this is something that will be helpful to you at times in certain problems, is recognizing that you can do that kind of thing. Let's do that over here in the second problem. Okay. So, first I have to clean it up. Clean up. And that means dividing both sides by that 4 before I try to do the 6th power of these. Okay. So I'm going to divide by 4 and divide by 4. And that means I have x to the negative 11, or x minus 11, I guess. I'm so busy talking about them in exponents, I got mixed up there for a moment. So I'm at this point. I'm going to rewrite it just to show the next step more clearly. Because in this next step, if I take this whole thing and go to the 6th power, it will cancel out that exponent, make it a 1. But I also have to do it on the other side. So that means now I have x minus 11 is equal to, big number here, 3 times 3 times 3 times 3 times 3 times 3 is equal to 729. Calculator is a wonderful thing. And I'll add 11 to make that 0 and have just the x by itself. So that means x is equal to 740. If you put that 740 in here, subtract 11, and then on a calculator, do that to the power of 1/6, and then multiply it by 4, you'll get 12. And that would confirm that one. So fairly big number for this time at 740, but that's the number you need when you then change it by raising it to the power of 1/6, a small, very small number. And let's look here at this one, and we're going to do the same concept here. Let's see, this is really almost the same as B, and D is almost the same as well. But on this first one, C, we're not having to do any cleanup for it. Okay. So I'm simply going to square here and square here. So I have x minus 3, because 1/2 times 2 is 1. 5 squared is 25. Nice, simple, x equals 28. Okay. And on the other side, it's almost as easy, except that we have this multiplier here, and you have to get rid of that first. So if I divide both sides by 12, that goes away. X plus 7 to the 1/2. Oh, I meant to do that in blue, so I will still. X plus 7 to the 1/2 equals 36 divided by 12 is 3. Now, I could have put this, I could do this as the square root of x plus 7 equals 3, and then square both sides. Perfectly fine to do it that way. I just want you to see that there's another way to do that with these. So I am going to do square on both sides. And the 1/2 times 2 makes just the 1 there. And so I have x plus 7 is equal to 9. Subtract 7. X is equal to 2. So if I put 2 in there, 9 to the 1/2 is a 3. 3 times 12 is 36. Okay, there are a couple of variations here. First one, you have a square root, and a square root result has to be positive, and this one's not. So when you see that, you immediately can say no solution. However, on this next one, you look over here and there's a negative, and it looks as if you would say no solution, but it's a trick because you can't make that decision until you have cleaned it up. And therefore, the first thing you need to do here is divide by -2 on both sides and see that you have a square root of x plus 4 equals, oh, those negatives cancel out. Now we have a positive, and that means it's legal. So I'm going to even write here, now it, this is not working for me. Let's figure out why. Uh-oh. Something went wrong. Please wait. I'm not sure what went wrong. Things seem to be better now. Now it is possible. Now it is possible. So since it is possible now, that means I can continue working with it. I can square here, and the square root and the square will cancel out. But I also have to square on this side here. So I have x plus 4, and then 14 squared. Let's see, 14 squared is 296, no, 269, 296. And if I subtract 4, I have 292. Okay. If I put 292 in here and added 4, I get 296. The square root of that is 14 times -2 would give me -28, and that would be correct. So these are interesting ways to look at the fractional exponents and the radicals and things you can do with it. And remember that if you have a negative number, you can't find a square root that will give you a negative number. But sometimes that's misleading, and you might have to see that after you do a step or two, it now is a positive. Important to recognize that. I hope that helps. Thank you for watching and listening.